Hello everyone. In this presentation, I'll talk about building a data lake using AWS services. Data lake is a progressive approach where data is collected from different source systems and is stored at one central place. This raw data can be further converted, transformed to make it more optimized for different business requirements. In this project, I downloaded data from New York City Taxi and Limousine Commission website. I downloaded 1 month data for Yellow Cab. This data was uploaded to AWS S3 bucket, which worked as raw data source for my project. From there, I created metadata catalog using AWS Glue service. I further optimized the raw data using AWS Glue ETL job. And once the data was optimized, it was consumed by different AWS services, namely AWS Athena and AWS QuickSight. Here's the solution architecture of my project. On the left-hand side, I have shown possible source systems. So in this project, I have collected data from one of the source systems. In this case, this is a data coming from TLC website. AWS offers a service called Glue, and Glue has a component called Scroller. Scroller does auto discovery of the source data to create metadata and registers it in Glue catalog. So in my project, I stored all the data into S3 bucket and then used Glue Scroller to read the raw data and registered the metadata in Glue catalog. Now the raw data is available for any kind of query using different AWS services. However, the raw data is in CSV format, and to optimize the consumption process, it is required to transform that data. In the architecture, I am showing the creation of Glue ETL job. The Glue ETL job is doing multiple things. First, it is creating an ETL job that does the transformation from CSV format to Parquet format. I'll talk about the Parquet format in little more detail very shortly. And once the data is converted, it's more optimized for consumption. This optimized layer is again stored in an S3 bucket. And here in the solution architecture, I'm showing that this rate data is ready for consumption by different services. Amazon Athena is a serverless query tool which can query directly against S3 data without the need of storing that into any database. Similarly, Amazon QuickSight is also a powerful tool which can build visual portals by reading data straight from S3 bucket. QuickSight is supporting so many data sources, and again we'll see that in a little more detail very shortly. Now with that introduction, let me walk you through my project details. First, I went to the TLC website and downloaded 1 month data for Yellow Cab. This data I uploaded to S3 bucket, which is working as source system for me. I also wrote a Lambda function which copies data from one S3 bucket to another S3 bucket automatically whenever there is a change in the source bucket. So this is very helpful in creating a real-time ETL to incorporate any change happening in the source system. However, in this use case, I didn't add that specific step. Now, once I have my source data on the S3 bucket, then the next step is to create the AWS Glue service to build metadata. So as I mentioned, Glue offers crawler, and crawler essentially looks at the source data and based upon an IAM role provided to it, it creates metadata detail in a database. In this example, I created a database NYCDB, and once crawler was executed, it created R3 NYC taxi table which has classification of CSV. So now the schema is created. That means that this data is available for consumption by different AWS services. For example, AWS Athena, QuickSight, Redshift, Spectrum, etc. However, it is always the best practices to convert that data in a more optimized format for better consumption experience. So now I'll show you how to create a Glue ETL job to read from the source data and convert that into a more optimized format. Here I have converted the data format from CSV to Parquet. Parquet offers much better compression mechanism. In this particular example, I have used Snappy, and also Parquet is columnar in nature. That means that the IO can be significantly less if we are just using fewer columns and not reading every single attribute of the whole data file. Now I'll show you a step-by-step example of how to create Glue ETL job. So first I have to configure the job by specifying the job name and other properties. Then I have to define a data source. Here I have defined the data source as the raw metadata table I created earlier. Then I have to define the desired target format. In my case, I'm going to store the new target structure on Amazon S3 bucket, and this bucket is different than the source bucket, and the format is Parquet. It also gives me option to map the target structure with the source structure. So that means I can do any transformation. I can change it to a canonical data model where we can provide a standard format across the enterprise. Once the mapping is complete and this step is complete, then we can save the job. Glue ETL generates a script automatically, and it also generates a diagram that's a good pictorial depiction of all the steps involved in the ETL job. Once the ETL job is created, then I executed the job. Behind the scene, it uses Spark for running, and it is using AWS EMR service for that. As you can see, once the job completed successfully, it created an optimized table structure, which is R3 NYC optimized, and you can see the format is Parquet. Now, in the next section, we will see the benefit of optimization of data. Apart from creation of a canonical model, we can see that how the consumption experience can be improved. Now, for data consumption, I've used AWS Athena. This is for query processing, and here I'm showing you two examples. In the first example, Athena is running against raw data, and you can see that data scanned is 733 MB and total runtime is 3.15 seconds. Now I run the same query against the Parquet format, and here it is. You can see that runtime has reduced to 1.1 second, and data scanned is only 73 MB. So clearly it uplifts the user experience significantly, and that's the reason we should always optimize the data for end user consumption. And this performance improvement is for the same volume of data. Now I'll show you another example of data consumption. Here I've used a visualization tool, QuickSight, and QuickSight is a BI tool that supports wide number of data source formats. In my example, I have used Athena as data source. So first step is to create a new Athena data source. And here we can define a new data source name, and that can use the metadata catalog that we created earlier. So here we are using the optimized layer created in the last step, and it offers two options. One is to import a Spice for quicker analytics, and the other is directly querying your data. Spice is a paid option where it provides in-memory processing capability for much faster processing. In this example, I just used the query option. So now you can see that it's reading the optimized layer, and it can look at the data available. For analysis, I created a calculated field which is extracting the hour of the day from the pickup date field. My idea for doing that is to get distribution of counts across different hours of the day. So creation of visualization is very easy. We can see that how the field and the data looks like, and then I generated a very basic visual interpretation of what I was looking for. Now you can see that from this diagram that most of the pickups are happening between the hours of 16th hour day and 23rd hour of the day. So between 4 p.m. to 11 p.m. the number of pickups are really high. In summary, data lake is becoming extremely powerful these days, just for the reason that compute and storage can be decoupled, and that gives huge scalability advantages. And again, this is a big shift from building a monolithic application to microservices based application. So manageability is much easier, scalability is easier, availability is higher, and this is becoming very popular day by day. That's all I have in this presentation. I hope you enjoyed. Thank you very much for watching it.